Hi everyone. So this week we're going to start on chapter 16, which is a pretty easy chapter. It's pretty short too, so I might actually get through it in one slide presentation. It's called Digestion and Absorption of Feed. So I really like this topic. So hopefully you'll like it too. Anyway, so first thing, let's start off looking at the digestive system. So this is the digestive system of a pig. And the pig is what's called a monogastric animal, meaning it has a single stomach. And remember, the pig's digestive system is very similar to the humans. So if you learned about human digestion, maybe in high school or somewhere else, that is very similar to pig's digestive system. So it really starts off with salivary glands in the mouth, and they secrete enzymes that break down starch. So digestion really starts in the mouth. You might want to remember that for quiz. And then the food travels down the esophagus to the stomach. And then in monogastrics, the stomach is relatively small. And food stays there, compared to ruminant, stays there a relatively short time period. So the food fills up the stomach and then passes from the stomach into the small intestine. And the small intestine is where nutrient absorption happens, and that's really important. Meanwhile, you have a very important accessory digestive organs, which is the liver. The liver produces bile, which is stored in the gallbladder, and the pancreas produces pancreatic juice. Pancreatic juice breaks down starches, and bile emulsifies fatty acids. So you have the stomach, which I should have said earlier, secretes hydrochloric acid. So that acid breaks down protein. Starches from amylase in the mouth start breaking down starch. Protein broken down in the stomach. Fatty acids broken down through bile secretions in the small intestine and a little bit in the stomach. And then the pancreas secretes pancreatic juice, which further breaks down starches. So that's the small intestine. And then from the small intestine, much of nutrients are absorbed into the bloodstream through the small intestine. It's very vascular. And then the residual food that's mostly digested goes into the large intestine. And the large intestine in a pig is large in diameter, but it's not very long. And basically what happens there is you have some fiber breakdown in what would be called the colon, and that helps to break down any fiber that the animal hasn't digested. They don't digest fiber very well, so not a whole lot happens there. Moisture is absorbed, and vitamins are synthesized in the large intestine. And then the residual food passes out of the animal in the form of fecal material. So that is a pig's digestive system. If we look at the digestive system of a horse, if you remember from the previous chapter, horses are what we call hind gut fermenters. Horses have a relatively small stomach. Similar to, compared to the size of the animal, it's similar in the size of a pig. And so their stomach is relatively small. So horses, as you probably know, if you have horses, they eat constantly. And the food stays a very short time in their stomach, passes through into the small intestine, and then goes into from there goes in through the small colon. Meanwhile, it's being broken down. And finally, the food gets to the cecum, which really is like your appendix. And that is where a huge amount of fiber is broken down. So a ruminant animal, like a cow or a goat or a sheep, they have a rumen, and that's part of their stomach. A horse just has a single stomach, so it's a modified monogastric or a hind gut fermenter, because the fiber that they eat, which horses exist solely on a fibrous diet, is broken down in their cecum. So horses are probably the most inefficient at digesting fiber compared to all the other fiber digesting animals. And if you've had horses, you know they're also prone to many digestive problems like colic. Colic can be caused by excessive gas. Colic is just a sign of pain, and can be caused by gas, can be caused by a twist in the colon, can be caused by all sorts of problems. So horses have this hindgut fermenting area to break down fiber. Also, that's the same with rabbits and with guinea pigs. Oh, one of my favorite animals is the chicken. And the chicken is also considered a monogastric because it has a single stomach. You have to remember that chickens evolve differently than mammals. First of all, chickens evolve for flight. So everything about their digestive system is, evolutionarily adapted for flying away, flight. So their digestive system is very simple and it's very efficient. So birds don't have any teeth. They don't chew their food. They swallow it. It goes into a pouch kind of in their neck, and that's called the crop. And from there, food is moistened. They actually have the enzyme amylase, breaks down starch, moves to the true stomach, which is the proventriculus, on into the gizzard where the food is ground up, and then it moves into the small intestine. And birds have a pancreas just like you do, and it's in this area called the duodenum, which is the first curve of the small intestine. So they still have the pancreas producing pancreatic juice. They have the liver making bile being stored in the gallbladder. So that's very similar to the pig and really to all animals. And then the food goes through the small intestine, which for birds, because of their adaptation for flight, is relatively short compared to a pig. And then they do have, theirs is paired, so it's called a ceca rather than cecum. And that is where fiber is broken down. And birds are not fiber digesters. They eat fiber. You see chickens on a pasture eating, fiber, but grass or alfalfa, but they don't digest it very well. So, but some is broken down here, and they manufacture B vitamins and things like that. And then their feces is expelled through the vent. So that's the poultry digestive system. Very, very efficient and adapted to flight. So remember kind of what we just talked about with the pig. A non-ruminant or monogastric has a single stomach, non-compartmentalized. It doesn't really depend on microbes to break down fiber. Digestion is pretty much accomplished through the secretion of digestive juices or enzymes. And examples of monogastrics are pigs, poultry, dogs, cats, and humans. And pretty much the types of food that they rely on is concentrate food. So they need feed that's dense in calories and contains adequate amount of carbohydrates and proteins and all the nutrients we learned about in the last chapter. So basically the stomach in a non-ruminant takes in the food and meters the flow of food that's been ingested into the intestine. And like I said, the stomach also produces a very strong acid, hydrochloric acid. And I'm sure maybe you've heard of racehorses or humans that get that have problems with excessive acid being produced in their stomach, and that can cause an ulcer, and that is a very serious condition. The small intestine, like I said, is the primary site of nutrient digestion, enzymatic action, and absorption. The primary source of enzyme production is the pancreas. Talked about that. So they give specific names of enzymes. Trypsin and chymotrypsin break down protein. Amylase breaks down carbohydrates. Lipase breaks down fats. And those are the names of, these two are the names of enzymes. The colon, the large intestine, primary site of water absorption in horses, which are the hindgut fermenters. That is where they break down fiber, like I already told you. Now let's take a look at the miraculous ruminant animal. So much of a cow's digestive system is taken up by their huge four-chambered stomach. So you can see the four chambers of the stomach are the rumen, the reticulum, the omasum, and the abomasum. So the rumen is, I think I'm going to talk a little bit more about this, is the largest chamber. And if you did a cross section of this cow, that's what this little dotted line is, you could see that the rumen really occupies a huge capacity of the cow's abdomen. So cows can hold a huge amount of food, but you have to look at what they're eating. Cows can eat corn stalks and really coarse fiber. They are the best digesters of roughage in the world. So let's talk about ruminant animals. The rumen, like I said, is the largest compartment in the stomach. Remember, the stomach is broken into 4 chambers, and the rumen is the largest. The rumen serves as a fermentation vat, and in there, in the rumen, is a huge microbial population, all different kinds of microbes, bacteria, protozoa, fungi, and yeast. And also, there are what we call volatile fatty acids, and those are the byproducts of fermentation, and they are really the source of energy that are absorbed by ruminants like cattle, sheep, and goats. The reticulum is a small stomach that kind of hangs down in front of the rumen, and it has a honeycomb type structure. If you consume tripa, or you have heard of that, that is the stomach that is consumed by people. It's washed and bleached and cleaned, but you can still see the honeycomb structure. It's in menudo, if you like menudo. So the reticulum is known for trapping foreign objects, and you can see how it could do that. If a cow eats like a nail or something like a piece of wire, it would drop right down into the reticulum. You can see, I'll switch back to that picture. You can see how from the esophagus, the reticulum is this pouch right here. And so any foreign objects would drop right into that. And that is a danger with feeding with cows, because they will have a big mouth and they lick up everything. And sometimes when that happens, the disease is called hardware disease. And those sharp objects can perforate the reticulum, and right in front of the reticulum is a chest cavity where the diaphragm is, and inside that is the heart and the lungs. And so sometimes that nail or piece of wire can work its way into the heart. And really the cow shows the cow just basically goes downhill. She doesn't look very good. She loses weight. She's skinny. She doesn't have much an appetite because she has this chronic pain and this piece of wire that's migrating through her body. And a lot of times those cows die. So one of the things we do with cows today, not so much today, we still do it on some dairies, but we give the cow a magnet. And the magnet sits in that reticulum. And when a piece of wire is swallowed, or a nail or anything metal, the magnet grabs a hold of it and just holds it there. And then when the cow is harvested, after it lives its productive life as a dairy cow, you can actually see the wires and things stuck on that magnet. So the other two stomach chambers in a cow is the omasum. And the omasum really just is kind of like the brakes. The omasum is called the many plies. It looks like a book. It has it doesn't really look like a book, but it has lots of thin layers in it. And it's kind of like the brakes sending food into the abomasum. And by this time, the food that comes from the rumen and the reticulum looks like a green slimy substance without a huge amount of fiber. A lot of the fiber has been really broken down by the microbes in the rumen. So the abomasum is important because it is the true stomach of the animal, and that is where acid is secreted. And it's very similar to the stomach of a pig or a human. And this is important because the abomasum is the only stomach that a baby calf can use to digest food, because the rumen takes a while to get started. So that's why baby ruminants have to rely on milk from their mom until they're about 3 months old. And after that, even within a month, the rumen will start being inoculated with bacteria, and the rumen will start breaking down some fiber, but not enough for the animal. So usually with baby calves, they're on pretty much a milk and grain diet, right? Milk and grain. Milk is protein, grain is carbohydrates, until they get about 3 months old. So really the entire system of a ruminant is designed to break down fiber, and the fiber in the form of cellulose and hemicellulose in forages. So ruminants digest fibrous feeds via microbial action, and they have a symbiotic relationship with those microbes. No mammal produces the enzyme cellulase. Only the microbes do, and that's what's required to break down fiber, which is called cellulose. I'm almost out of time. So microbes synthesize amino acids and proteins from ammonia, and this allows for conversion of low-quality feeds to meet the nutritional requirements of an animal. Ruminants also manufacture vitamins and the water-soluble vitamins and vitamin K in the rumen. Okay, I'm about out of time. I think we made it through that.